Check. Well, hello guys. I hope I am live. Hello guys. Please don't mind the feedback. I was just trying to listen to my voice and I was trying to analyze whether there is too much of a lag between what I say and what you hear, or whether it's considerably small. Well, it appears to be small for that matter. Just waiting for a few people to come on before we can begin. Some of you are available. You can just let me know in the chat if you're able to see and hear me clearly. Well, I can see and hear myself clearly, so I believe that if somebody is not able to, it has to do something with their internet connection or their device quality. Nevertheless, I think we are good to go now. Since it's already time, we are 3 minutes past 12 o'clock. Yesterday, we saw what units mean, right? We have just started this bridge course in physics, which will help class 10th pass students to understand those concepts which are going to be extremely important for them, given the fact that all these topics which you will learn in the bridge course will continuously be used throughout all other topics in 11th and 12th, which is why you cannot afford to not understand topics in the bridge course. So out of the 4, 5, 6 chapters that we have planned to cover in this course for the next 1 or 2 months, we are going to spend maximum of our time in vectors and calculus, which are chapter number 4 and 5, if I'm not wrong. Because these are the ones which are going to have the greatest importance throughout the syllabus. And as of now, we have started with some warm-up chapters like units and dimensions. Then we will go to error analysis, followed by instruments, and then we will enter vectors and calculus, right? So we just started with units yesterday. Yesterday was the first class. Today is the second one. For those of you who have joined in late, well, you haven't really missed much. And make sure that you start attending live classes, because if you attend classes live, I can get your messages in the chat. I have been reading all chats, and in case if somebody has a doubt, you can always ask it in the chat. And it's always better, to make the whole class interactive. Like I ask a question in the class and then you answer it in the chat. It gives me a feedback that you're able to understand things. Anyways, the stuff that we are learning right now, I don't think you should find a lot of difficulty in understanding it. But a correct answer in a chat just gives a reassurance that indeed you are understanding stuff, and it makes the whole class interactive as well. So do advertise about this bridge course to your connections, to your friends who have just finished their class 10th, right? And who would find this useful. And as far as this class is concerned, we have finished units yesterday. You can just have a recap from the videos of the previous class. We will not waste time revising that since the video is already up. You can check that. And today we will move to dimensions. As I've already told you guys, I'm not going to spend too much time on these chapters because these are not as important as some of the other chapters that we have to cover in the bridge course. But nevertheless, it's inevitable for you to have an understanding of these, because there is definitely one question which comes from units and dimensions every year in JEE Mains, and for that matter in JEE Advanced also. And it's usually one of the scoring questions. So you cannot afford to lose that question. You have to get it right. And that's the reason why it's important for you to give a small amount of focus on units and dimensions towards the beginning of your preparation, because when the main topics start, you will never get time to come and revise these subsidiary topics. So what are dimensions, first of all? For those of you who have finished your 10th, I believe that this would be a new term for you. Maybe you would have heard of units before, but you wouldn't have heard of dimensions. So what do we mean by dimensions? To understand that, I will first put the definition, and then we will carry on understanding from there. So yesterday we saw what a physical quantity is, what a unit is, what SI units are, and what fundamental physical quantities are. These are the 4 things that we roughly covered yesterday. So dimensions of a physical quantity are the powers to which fundamental quantities have to be raised in order to represent this quantity. Well, maybe it's quite possible that as of now this definition would not make too much sense to you, but let's try to decode the meaning here. Yesterday what we saw is we have 7 fundamental physical quantities, isn't it? As of now through international conferences, what has been established in the scientific world is that there are 7 physical quantities. In the future we might have more, we never know, but as of now, yesterday we saw all those 7, and what I told you is you can pick up any of those 7 quantities and multiply them or divide them with each other any number of times, and every such combination represents a physical quantity. Every such combination represents a new physical quantity. So I also asked you a question, how many physical quantities are possible? And what we saw is there can be countless physical quantities, because you can have so many, like huge number of combinations, right? Because when you have 7 things, 7 physical quantities to choose from, and you can choose any physical quantity any number of times, and you can make any combination and multiply them or divide them, then just imagine, like there are, it wouldn't be wrong to say, infinite physical quantities which are possible. So what does dimensions of a physical quantity mean? So what were our fundamental physical quantities? We had mass, we had length, we had time, we had electric current, which was represented in amperes. Then we had thermodynamic temperature, which was represented in Kelvin. Then we had amount of substance, which was represented as mole, MOL. And then we had luminous intensity, which was represented as cadence. So 1, 2, 3, 4, 5, 6, 7. We have 7 fundamental physical quantities. Hello, Shaurya. Good to have somebody writing in the chat. So take any physical quantity and see that to get this physical quantity, which fundamental physical quantities will I have to choose, and what should be their powers? That represents the dimension of this physical quantity. So let me just straight away hit an example, and then it will be clear to you. For example, let's pick up force. Okay, I've been using force again and again for some reason. I really like that example because I understood dimensions in my days using force. Hello Astrid, good to see you writing in the chat again. You were quite active yesterday also. So we have force, and yesterday it was Astrid only, I think, who had told that force is, the formula for force is mass into acceleration. So I'll just put that. right? So, and we knew that acceleration is nothing but change in velocity by time, mass into change in velocity by time. Okay, so let's continue with this example of force in the next slide. So force just now we saw is mass into change in velocity divided by time, correct? Now, velocity, change in velocity is nothing but change in displacement by time. Can I say that? So keep mass by time aside. And can I say change in velocity is nothing but change in displacement by time? Or, it's not change in displacement. It is, no, I shouldn't say, I can't say it's change in displacement by time. I'm sorry. That's not what I meant. So velocity, change in velocity is nothing but final velocity minus initial velocity. Correct? By time. So I hope you're trying to understand the paths that I'm taking here. So we have mass by time. Just give me a minute. Somebody is at the door. I'm back. So final velocity is nothing but, okay, when you look at the formula for velocity, what is the formula for velocity? Very simple question. It is nothing but displacement covered by time taken. Correct. So final velocity is whatever displacement the body had covered in the final interval divided by time, right? So can I say it's nothing but displacement by time only? Initial velocity is the displacement that it covered in the, so I'll call this as displacement 2 and I'll call this as initial velocity as displacement 1, because let's say in the initial velocity, in the initial time interval, the displacement that it had covered, I'll call that as displacement 1. Now, the point is, just give me a minute. I'll just be back. There was some background noise which I had to work with. Nevertheless, so mass by time into displacement 2 minus displacement 1 by time. Now, you don't really have to subtract these. Like you don't need the values here because we are not trying to calculate the numeric value of force, right? So when I'm talking of dimensions, displacement 2 minus displacement 1 will have the same dimension as displacement. That's the thing that you have to understand here. Displacement 2 minus displacement 1 will have the same dimension as displacement. So this displacement might be 10 meters. This might be 5 meters. I'm not denying. But I don't care about the numerical value here, because this is also going to be meters and this is going to be meters. And when you subtract these, like let's say you have 10 and 5 here, right? So when you subtract 10 and 4, you'll get 6 meter. But ultimately, the difference of displacement 2 and displacement 1 will also have meter as its dimension, right? So when you subtract 10 meter and 4 meter, you get 6 meter. So this meter does not change. It is still the same. So that's why displacement, when you subtract them, the dimension of the subtracted quantity is also going to be displacement only. So mass is nothing but m, time is nothing but t, into displacement is nothing but L, right? Yesterday I told you we represent displacement using length, and that divided by t. So how do I represent force now? What are the dimensions of force? Mass into length divided by time square, right? Which is nothing but mass power 1 into length power 1 into time power minus 2. These are the dimensions of force. These are the dimensions of force. Now, I started with acceleration. From that, I went to change in velocity. Then from change in velocity, I went to displacement. Like I had to finally come to displacement, and only then I could stop. Because mass is a fundamental physical quantity. So that's fine. Time is a fundamental physical quantity. That is also fine. But this velocity is not a fundamental physical quantity. The acceleration, from where we started this whole journey, the acceleration wasn't a fundamental physical quantity. So I had to come all the way to displacement. And in fact, I had to come all the way to displacement by time. And only then I could stop. So that's the point that I'm trying to make here. This is how you work with display. This is how you work with dimensions. You have to take that quantity and you have to break that quantity down all the way to fundamental physical quantities. And what do you mean by breaking down? Like from acceleration going to velocity, from velocity's formula going to displacement. And now I know that, okay, displacement is fundamental. So now I don't need to do anything. So you have to know formulas and then you have to break it down all the way to represent dimensions, right? So let me just run another example for you. And then it should be even more clear. So just a minute. I haven't been checking chats. Let me just see if something else has come up. All right. So let's take another physical quantity. So our next physical quantity is going to be density. Now remember, to get the formula for to get the dimensions for density, I first need to know the formula for density from our class 10th. Okay. To get the dimension of any physical quantity for that matter, you have to know its formula. And then you'll have to know the formula for the quantities involved in that formula until you break the whole thing down to fundamental physical quantities. Like when I took the force example, I knew force is mass into acceleration. So first of all, I needed to know the formula for force. Then that was not enough. I needed to know the formula for acceleration, which was change in velocity by time. Even this was not enough. I needed to know the formula for velocity. And then I could come to displacement. And then when I came to displacement and time, then I knew mass is fundamental, displacement is fundamental, time is fundamental. So now I don't need to do anything else. So to get dimensions of a physical quantity, you have to know the formula of that quantity, and you also have to know the formula of the quantities involved in the formula of that quantity until you keep going all the way down to fundamental physical quantities. I hope I was able to make sense here. So what is the formula for density? It's nothing but mass by volume. Remember it from your class 10th? Now my question to you is, what are the dimensions of density? So whenever you use these brackets indicate dimensions. These brackets indicate dimensions. So how will you get the dimension of density? So mass is fine. Okay, I have one fundamental physical quantity. So this is fine. But what about this volume? Is volume a fundamental physical quantity? The answer is no. Volume is not, right? Is volume present here? Only these are your fundamental physical quantities, these 7. Can you see volume here in any of these 7? No. So you need to know the formula for volume also. And your formula has to somehow lead you to one of these 7. And only when you reach these, only when you are left with only these 7, or only the relevant ones from these 7 in the formula, only then you are done with the dimensional analysis. So I know that if you remember a cube, how do you calculate the volume of a cube? Length of one edge into length of another edge into length of another edge, right? Length into length into length, correct? So volume is nothing but length into length into length. And remember, even if I'm not taking a cube and if I'm taking a cuboid, does that make a difference to the dimension of volume? No, right? This is your length, this is your breadth, this is your height. If I'm talking of volume of a cuboid, then it will be length into breadth into height, right? But the dimension of length is also length, the dimension of breadth is also length, the dimension of height is also length, because ultimately all these 3 physical quantities represent length only, right? So when I'm doing dimensional analysis, whenever I'm doing dimensional analysis, I don't care whether I'm taking length, breadth or height. I just care about the dimension of length, breadth and height. And dimension of length is also length, dimension of breadth is also length, dimension of height is also length. Don't get confused between this length and this length. This length is the name of this edge, right? And this length is the dimension of this physical quantity length, right? So you take any body in the world, you take any shape in the world, the dimension of volume is going to be length into length into length only. That is the reason why SI unit of, what is the SI unit of volume? SI unit of volume is meter cube, because it is meter into meter into meter, right? Length into length into length. So whether you take a circle, whether you take a sphere, not circle, volume is defined only for solids, right? So circle is not a solid. Whether you take a cuboid, whether you take a closed hemisphere, whether you take a sphere, or whether you take a body of some irregular shape also, if you measure its volume, it's going to be length into length into length only, right? Dimensions, I'm talking about the dimensions. I hope you're getting it. I'm talking about the units of volume, which is length into length into length. So now I'm done. Mass is a fundamental physical quantity, m, and this is L into L into L. Do I need to break it down further? Can I break it down further? That is rather the right question. Can I break mass into something else? No, because mass is one of these 7 quantities. Can I break length into something else? No, because length is also one of these 7 fundamental physical quantities. So I just have to leave it here. So that's all. Your dimension for density is nothing but mass by length cube, which is nothing but mass power 1 into length power -3. And I can say it is time power 0. Why? Because time power 0, anything to the power 0, a power 0, what is it? 1, right? So it is this into 1, something like that. So usually we use MLT everywhere. So for most of the things that you're going to see early on in your syllabus, you are only going to deal with them in mass, length and time. Like these are the 3 that you're going to use the most. And these obviously later on when you see more and more formulas, then you'll have to use 4, 5, 6, 7 also. But for most physical quantities early in your syllabus, early in your 11th, it's only going to be about MLT, right? Because you will study current in your 12th. You will study thermodynamics towards the end of your 11th. Mole also you will study when you study thermodynamics towards the end of your 11th. So these are going to come later in terms of your syllabus, not later in terms of all of them exist right now, but you are going to see 4, 5, 6, 7 later in your syllabus, and you are going to see 1, 2, 3 quantities related to 1, 2, 3 early in your syllabus. So now the point is what I'm trying to tell you here is, so you have MLT AK mole CD, right? 1, 2, 3, 4, 5, 6, 7, these 7. So whenever you take mass power 1, whenever you take length power 1, and when you divide it with time square, you should know that this represents force. Like, I'm not expecting you to memorize this for every physical quantity. You can derive it, obviously. But you should know that it cannot represent any other quantity other than force. Like, this can never represent acceleration. No. Acceleration has its own dimensions. What are the dimensions of acceleration? Acceleration is nothing but change in velocity by time, which is nothing but change in displacement, displacement 2 minus displacement 1 by time, and basically it will become time square because it's final velocity v2 minus v1 by t, final velocity minus initial velocity by time. Final velocity is nothing but final displacement by time. This is initial displacement by time, and 1 by time is already there, correct? Now this, when you subtract these two, final displacement minus initial displacement is going to be displacement only. So ultimately you are going to have meters only. So this is going to be length by time only, right? And that divided by time, right? Because I already told you, no, when you are subtracting 6 meter from 10 meter, you are going to get 4 meter. So this is also having dimensions of length. This is also having dimensions of length, and their difference, which is another physical quantity, is also having dimensions of length only. So I can just subtract these two and say it's length. So what is that? What are the dimensions of acceleration? Length by time square, right? So when you take length from this and when you divide that with time square, then this represents acceleration and it cannot represent anything else. As much as it is important for you to understand that this represents acceleration, it is also important for you to understand that this cannot represent anything else other than acceleration. So this combination, right? This is one combination. This is another combination, right? And what is this a combination of? It is a combination of these 7 physical quantities, right? Because here, if you look at its whole dimension, what is it? What is it like? Mass power 1, length power 1, time power -2, and all other power 0, right? What does power 0 mean? I'm not taking it even once. Power 0 means I am not taking the fundamental physical quantity at all. So this combination, this is a possible combination, right? It is a possible combination. So this combination of these 7 physical quantities represent force and nothing else. That is something that I want you to understand. And let's look at acceleration for that matter. How do I represent what was acceleration? Length by time square. Just now we saw it here, length by time square. So when I represent it as a combination of all 7, it is, what are the dimensions of acceleration? What can I say? You're taking length once, you're taking time twice, but you're dividing it. So that's why you have this negative sign, because you're dividing it. And then everything else power 0, because you're not taking mass, you're not taking current, you're not taking temperature, you're not taking moles, you're not taking cadence. So this is another possible combination, and this combination only represents acceleration. It does not represent anything else. Getting my point? So what is the difference between this combination and the other combination? This part is the same for this. This part is the same for acceleration and force, but what's differing between these two is in force you have mass power 1, but in acceleration you have mass power 0. So you see, there will always be at least one difference. Whenever you look at dimensions of one physical quantity from another, there will at least be one difference between one of these 7 quantities, between the powers of one of these 7 fundamental physical quantities. And if there is no difference between the powers of the 7 fundamental physical quantities of 2 physical quantities, then both these physical quantities have to be the same. They can't be different. That's the point, right? So I hope people were able to understand. Hi Kishore, I saw your message a little late. I was not in the chat section, but anyways, good to have you here. All right. So moving on. Now I think you guys completely understand what dimensions mean. So can you help me with the dimension of another physical quantity? Let me give you one. Let me think of a physical quantity which you would have studied in your class 10. Fine. Give me the dimension of work. You would have studied work. Yeah. Give me the dimension of work. If somebody knows. Speed is very simple, Kishore. Speed is very simple after having looked at a lot of other examples. Speed is simple, but if you guys remember the dimension for work, sorry, obviously I don't expect you to remember the dimension, but if you remember the formula, then using the formula you can do the same process to get the dimension for work. So just try it on a pen and paper, and just make sure, whenever you're attending these classes, you have a pen and paper in hand, because I've already told that I'm going to give you problems in the class, right? We are going to do problems, and it's good to see. Kishore says, so let me say, Kishore is telling that it's m power 1, l power 1, t power minus 2, and Suyog, hi Suyog, maybe this is the first time I'm calling your name, good to have you here. Suyog says it's m power 1, l power 2, and t power minus 2. Let's see who's right. And obviously take this competition positively. Don't take it to your heart, even if you're wrong. Doesn't matter, we're all here to learn. So work is nothing but force into displacement, if you guys remember. Correct? This is the formula. Yo, hi, so you're a JEE 2022 aspirant, then yes, perfectly, this bridge course is for you, because you have finished your, oh no, you're 22 aspirant, which means you have already finished your 11th. That's fine anyways, you can still learn in case you're interested. So work is nothing but force into displacement. So just now we saw what are the dimensions. Now we are talking in terms of dimension. Okay. So what is the dimension of force? Just now we saw mass power 1. This is the dimension of force. Just now we saw. Correct. And then you'll have to multiply this with, don't put the brackets now. You have to multiply this with displacement, which is length. Okay, guys, I'm not saying I'm expecting you to memorize the dimensions of force. We did it just now, so that's why I'm remembering. I remember it. But even if you forget, you can always use the same process the way I taught you, breaking down from the initial formula, breaking it down all the way to fundamental physical quantities. You can use that process and you can get the dimension of force. Even if you don't remember it, even if you don't remember the dimensions formula, doesn't matter. This is your length. Now, just have to multiply those two. So work is nothing but mass power 1, L power 1, T power minus 2 into L, which is nothing but mass power 1, L power 2, T power minus 2. Correct? So these are the dimensions of work. So do you see? You need to know the formulas. Unless you know the formulas, you can't break it down all the way to fundamental physical quantities to get the dimension. Okay? So who was right? Out of these two folks, so Yog is right. Okay, sure. I hope you learned, I hope you were able to figure out the mistake that you did. That is the whole intention of doing a problem in a class. Okay, so that's great. That's great. We learned how to find dimensions. I would like to give you a small note here. This note is important because maybe later on you can't really prove it right now. Like, you do not have the necessary mathematical tools. You do not have the necessary mathematical tools to prove the information that I'm giving you right now. But it is still important for you to have this information, and that's why I'm giving it to you. All trigonometric identities, or in fact, let me say, the following quantities the following functions are dimensionless. Number one, trigonometric functions. Number two, exponential functions. Number three, logarithmic functions. I'm not sure if you have heard all these terms before, but I'm still giving it to you. And number four, constants. So trigonometric functions are all your sine theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. All these six are your trigonometric functions. Exponential functions are your e power x, a power x, these type of functions. Logarithmic functions are your log x, ln x, these functions. Constants are numbers, 5, pi, root 3. All these are constants. All these quantities do not have any dimension. What do you mean they are dimensionless? When I say dimensionless, I mean to say that dimension of cos theta is equal to dimension of sine theta, is equal to dimension of tan theta, is equal to dimension of e power x, is equal to dimension of 5, and that's equal to mass power 0, length power 0, time power 0, and all the other quantities power 0. Which means you are not taking any of these fundamental physical quantities at all. Okay, so this is what I mean by this note. All these, whenever you see cos theta, sine theta, tan theta, e power x, 5, in fact log x also, sorry, I forgot to include log x here. So include log x also, dimension of log x also. All this 1, 2, 3, 4, 5, 6, and any such function of this type, any such function which falls under this category is dimensionless. Right? So whenever you see a formula like change in velocity, or let me say not change in velocity, velocity into time, or velocity into mass by acceleration into sine theta. If I ask, let's say this is a physical quantity, right? This whole thing is a physical quantity. Then what is the dimension of this physical quantity? For that, I need dimensions of velocity. Dimension of velocity is, I know the formula, it's displacement by time. So it is length by time. Dimension of mass is m. Dimension of acceleration, just now we saw it is length by time square, right? But what is the dimension of sine theta? Nothing, it is 1. Because just now I told you that all these functions, whenever they come in a formula, if any of these come in a formula, you have to treat them as dimensionless, which means you will not consider any of these fundamental physical quantities to represent them. In other words, it is nothing but mass power 0, length power 0, time power 0. And that means 1 into 1 into 1, which is 1 only, right? Doesn't matter. You can just leave it. Just ignore all these. Whenever you're doing dimensional analysis, ignore sine theta, cos theta, tan theta, e power x, log x, and all other constants. Just ignore them. Okay. So what is the dimension of these physical quantities? Length will get cancelled, and it will simply be mass into time. Okay. I don't know what this quantity is. I don't know what it represents, but what I know is that the dimension of this physical quantity is nothing but this. I don't know anything else about it. I don't know what it's representing. I don't know where it's come from, but I know that its dimension is this. Okay. So with this, we are done. However, I would I of course want to discuss, yesterday I told you, I want to discuss a couple of hacks which you can do using dimensional analysis. Okay. Let's say there is a question in physics that you see, which has a lot of, some question in physics is being asked. And then the final line of the question is, what is the force acting on the table? Right. What I'm trying to say here is, before this line, there is some information about what is happening on the table, like somebody is pushing it with something and some block is on the table, something is happening. I don't know, it can be anything. But ultimately the question is asking, what is the force acting on the table? And the options are 5 kg meter per second square, 6 kg meter per second, 4 kg per second, and option D is 10 kg meter square per second. Now, without putting any brain, without even looking at this information, is it possible for me to choose this answer? Some diagram is given, some table is given, some block is there, one more block is there, you're applying some force from here, there is some friction here, any random thing can be given, but the point is, finally they are asking this, and these are the options. Now, whenever options like this appear, do I even need to look at the question? That is my question to you. The answer is you don't. So this is a shortcut. This is a shortcut known as dimensional analysis. So whenever something like this is asked, like what's being asked here is, what is the force acting on the table? That means I have to choose an option which represents force, first of all. Whether it's 5, whether it's 6, whether it's 4, whether it's 10, that's secondary. But first we have to see whether the option that I'm choosing is indeed force or not, right? So to know whether it's force or not, I need to know the dimensions of force. What are the dimensions of force? It is nothing but I don't know what Kishore is trying to say. He's saying no weight, no force. I don't know what that means, but anyways, just follow with the explanation. So force, the dimension of force is nothing but, just now we saw mass power 1, length power 1, t power minus 2, which means its mass is nothing but kg, length is nothing but meter, t power minus 2 is nothing but second power minus 2. So it's kg meter per second square. So what I know is the dimensions of force is kg meter per second square, like the units of force. With the help of dimensional analysis, I know that unit of force is kg meter per second square. Now I can clearly see there is only one option which represents kg meter per second square. This option B, which is kg meter per second, is not force. This kg per second is not force. This kg meter square per second again is not force. So if these three are not force in the first place, then how does it matter whether it's 6, whether it's 4, whether it's 10? The constant will matter only if the dimension is right, first of all. And a lot of times in the options, dimensions, all 4 options have different dimensions. Whenever you see that, just close your eyes and go for dimensional analysis, because it will help you save a lot of time. Remember, if this option A was, so obviously I can see that only option A is kg meter per second square. Force is being asked in the question. The dimensions of force are kg meter per second square. Only one option has this dimension, so obviously this is my answer. I don't need to go for anything else. But in case option B also had kg meter per second square, then I couldn't blindly choose A, because this is also force, then this is also force, and this is also force. Now I need to choose whether it's 5 or 6. When dimensions are right, then constants will matter. Then we'll have to solve the whole problem to see whether 5 Newton is acting on the table or 6 Newton is acting on the table. But if dimensions itself are different, then I can do dimensional analysis and I can get the right answer. I hope you got the point. So this was one trick with the help of which you can solve a lot of problems very quickly. And it was a very important section. If you did not understand it once, just go back and revise it. And in case you have any doubts about it, leave it in the comments section. But make sure you get dimensional analysis right, because it's going to help you save a lot of time in the exam, and it's going to help you solve certain questions very quickly without even doing physics, right? Even dimensional analysis is also physics. I cannot say it's not physics, but you don't need to do other physical concepts. Dimensional analysis is one of the easy concepts in physics. Other topics might be a little difficult, and if you can avoid them and use dimensional analysis to solve a problem, then why not do that? Okay. So, but remember, even paper setters are getting lucky with time. Sorry, not lucky. They are getting intelligent with time, and they know students are using these tricks to solve the problems. So they do not give options with different dimensions these days. But you never know. You might get lucky and you might get a question like that. So another use of dimension is what is another use of dimension? It is conversion of units. Remember, I told you yesterday that a given physical quantity can have more than 1 units. Like your mass can be measured in kg, can be measured in grams, can be measured in micrograms, right? So all these are units for mass. So mass is a very simple fundamental physical quantity, so you don't really need to worry much. But sometimes you can have some complicated, some long, not long, some other physical quantities which involve a lot of fundamental physical quantities, and then somebody can ask you to convert it from MKS units to CGS units. So how will you do that? Like for instance, I might ask you that take force. What is the SI unit of force? It is nothing but newtons, and we know it is kg meter per second square, right? We have been doing it for a while now in the class. Like it is mass power, dimension is mass power 1, length power 1, t power minus 2, which means it's kg meter per second square. This is the SI unit of force. Like it's represented using newtons, but the dimensions are kg meter per second square. Now there is another unit of force which is CGS units. In CGS units, it's called dynes. Now, how do I convert 1 Newton to 1 dyne? The question is 1 Newton equal to how many dynes? How do I fill this blank? 1 Newton equal to how many dynes? You might remember the answer, but in case you forget the answer, then how do you solve it? So, whenever we are talking of CGS units, CGS means centimeter, G means gram, and S means second. So here in SI units, I have kilograms, I have meter, and I have seconds. So I have to convert this kilogram to gram, and I have to convert this meter to centimeter. So first of all, to do that, I need to know the dimensions of Newton, right? So that without dimensional analysis, I cannot do it. So let's say this quantity is x, okay? So 1 Newton is 1 kg meter per second square is equals to x gram centimeter per second square. Because whenever I'm talking of dyne is going to have the same dimensions, except the fact that units of the dimension will change. Like dyne is also going to be mass into length by time square, but mass will not be in kilograms anymore, it will be in grams. Length will not be in meters anymore, it will be in centimeter, and time will still be in seconds. That's what CGS means. Now the question is, how do I get this x? So you have, let's go to the next slide. You're right, Kishore. Initially you said 10 power 7. 10 power 7 was wrong. 10 power 5 is right. So you have 1 kg meter per second square is nothing but x gram centimeter per second square. So how many kgs is 1 gram? 10 power minus 3 kgs, right? So or how do I convert grams to kgs? So 1 gram is equals to 10 power minus 3 kgs. 1 centimeter equal to 10 power minus 2 meters. Correct? So when you carry out the calculations, when you replace 1 gram and when you replace 1 centimeter, what you will see is 1 Newton is equals to 10 power 5 times 1 Newton is equal to 10 power 5 times is what you will come across. This is your constant. Okay. So this is all I guess so far about this is how you convert between units. You know, whenever you replace this kg with gram, centimeter with meter, and you carry out the cancellation, finally these will get cancelled. Your meter, centimeter will get cancelled, kg, grams will get cancelled, and you will only be left with 10 power 5, because this 10 power minus 3, 10 power minus 2 will multiply, they'll become 10 power minus 5 and will go on the other side and become 10 power 5. So 1 Newton is nothing but 10 power 5 dynes. So this is how you have converted an SI unit, or you know the conversion between SI unit and CGS units because you knew the dimensions, and with the help of that you could carry this out. So this was one more use of dimensional analysis. So tomorrow we will just quickly wrap up dimensional analysis. Like we will do a couple of more problems on this conversion, and within the first 10 minutes we will wrap it up, and then we will start with the next topic, and that I believe was let me just check the schedule. I think it was error analysis, if I'm not wrong. Yeah, so tomorrow we will start with error analysis. We have quickly covered all the important aspects of dimensional analysis and units. So tomorrow I'll see you guys around. I hope to see you guys live again. Come live and attend it. Obviously you can watch the recorded lectures, but attending it live is always more is always better, because you can chat. You can put chat. You can put your messages in the chat, and I can read that, and I can respond to your doubts and obviously to your compliments as well, the way Kishore has given one right now. Thank you. Thank you for joining, guys, and I'll see you around soon. We'll see you guys. Bye bye.